Welcome back, people of the Commonwealth. So you made it this far in these AI tutorials. Congratulations. Today, instead of a project, I'm going to explain a bit more theory. I'll be explaining about what vectors are in machine learning, right? So let's get started without wasting any further time. So in machine learning, basically a vector is just a list of numbers, right? Array with numbers. So let's say we have a toy vector with color and shape. I've assigned two properties, right? Two characteristics. So each characteristic will have a number, and each number represents some sort of similarity to it. For example, I'll be using these. Uh, here you can see that 1 will represent red and 0 will represent a vehicle, right? And 1 in the second shape will represent a circular or round kind of shape, right? And 0 will be meant for green color. So any other value similar to 1 will be sort of roundish but not exactly a circle, and point 0.8 will be even less similar to the actual value of round. And similarly, value of let's say 0.9 will be a slightly different variant of red, and 0 is obviously green. These vectors can be extended to like multiple dimensions. So here I'm only using two characteristics, but you can have like 700, 800, 1000 plus vectors, 2000 plus vecters for a single sentence. So let's say I love dogs, so even that sentence could have like multiple characteristics and 1000 plus vectors, 1000 plus characteristic list, right? So traditional databases, what they do is like when you search for a red car, you would want to get a similar results to a red car instead of a specific red car. There is no specific red car, right? So what happens is traditional databases, they give you the exact search, but there are vector databases that we use in machine learning for AI. These vector databases, they will give you a similar result. The difference is exact versus similar. So whenever you want to find a similar result, you will be using vector databases to store those vectors. So basically this red car is represented by this vector, and to we want to find vectors similar to this vector, and we'll get this recommendation results, like we get the similar results. So uh, common use cases of these vectors is obviously the recommendation system. For example, your Spotify list, the songs that you listen to, they can have vectors. Your shopping list, your job description, maybe it can have similar vectors, and the most similar vectors will be recommended to you. So today I'm going to be using this simple example and run a code using Python in Jupyter Lab to see how actually you can implement your bare minimum code for this to understand this concept, right? So let's see, I want to search a red car and I have these vectors in my database. So I want to see the similarity between my search as well as these documents, right? We will call these results, we'll call these saved vectors as documents, okay? So let's move on. So I'm just gonna quickly open my Jupyter Lab terminal, cd desktop, cd projects, cd conda tutorials, conda activate LLMs, and Jupyter Lab. Please watch the previous video to set up this conda environment in Jupyter Lab if you haven't already, right? And also install sklearn and numpy pandas. Actually I'll be able to attach this file environment, and this should help you install all the required libraries. You can use this. Okay, I'll close these. So we can start with the code now. So I'm gonna explain it to you from the top. These two libraries are required for working with vectors as well as data, as well as larger data or arrays, right? We need numpy. So first of all, first of all, I have this. I'm gonna create a normal array for these vectors. I'll install it into toys. This is our variable, and numpy will create an array of these vectors with these values, right? With same 101.2, 0.9, and 1.8. So these will represent our documents, right? And we just name it for final result, for printing out the result, right? And we want to make a query regarding a red car. So we are going to create 1 0 another vector for a query. 1 will represent red color and 0 will represent a vehicle. So we need a red vehicle. Okay, that will be a query. We have also installed it, we have also made this numpy array for this. So after this, let's just run this code up to here. After this, what happens is we need to find similarities between two vectors, our query as well as each of these compared to each of these. So for finding similarity between two vectors, we have different methods, but the most common and easy to implement for us right now is cosine similarity. This is actually used to find the angle between two vectors. Like two vectors are this, and you get the angle between those if the angle between the two vectors in a three-dimensional area is like 0. So they are both pointing towards exactly in the same direction. That would mean that both vectors are same, right? And if I'll explain cosine similarity in a different video. For now, let's just move on and just see that I'm comparing query to the toys array and getting the similarities for those vectors, right? And I have after this after getting similarities, I just sort the array and then reverse the sorted array, so that will be descending order, and pick the top 3 indices, so the most similar indices from the top, right? From 3 I'm got this in top indices, and then I just printed out the result. So let's run this code. So this is the result. Is most similar to your query. Red car score is 1. So obviously we were searching for red car. This score is going to be 1 as vector for our query. 1 0 is pretty much same as 1 0 for red car, right? Second is a red truck. It is 0.98 score. So red truck is this one, 1.1 and 0.2. This is more similar to 1 0, right? Our query. And the third one is red balloon. The score is 0.78. So this is how the vector and databases work, vectors work. We use vectors in we'll be using vectors in our next videos for our project. So please understand this concept now, and you can implement it in whatever projects you like. You can have your own vector databases to store these, and you can actually customize lots of functionality between retrieving data from LLMs or to give prompts to LLMs, right? We'll be actually using the applications later on. I'll make a different video. For now, just understand the concept. So now that we have a result, we can move on to our next example. This is more of a real life example I'll be using, and instead of these toys, we can, instead of generating vectors on our own like this, we have just used 2 values. We can have like longer vectors, 1000 plus length vectors, right? So I'm gonna be using GPT's embeddings. We call those embeddings when we create vectors for those, and I'm gonna replace this code that we had with the GPT vectors, right? And actually run the cosine similarity on actual query. Let's see what we can do. So I've imported OpenAI. This is the next real life example. I imported OS and env. This is to load our env API env key. Please watch my previous videos for setting up this env file and key. So this code just basically loads the OpenAI API key into the OS. So OpenAI will use it by default, and this won't be required for now. We need NumPy and cosine similarity from sklearn, right? And this is also not required for now. So let's run this first. Fine, we load our API key and initialize our OpenAI object. That worked fine. So now we have our function called getEmbedding. So what this function does is it takes a text and it's gonna call the OpenAI API. It's gonna tell it to create an embedding for a text, and it's gonna be using this cheaper version of embedding. You can have like if you want to have expensive, more complex queries, you are gonna be using more expensive versions. But for now, for tutorial reasons, this is the cheapest to work with. For your practical purposes, you can upgrade to a higher model. So for now, I'm gonna be using this, right? This is a cheaper model, and then it's gonna be returning the NumPy array with the response embedding, right? And data type is obviously float 32. We can have higher data types, but this is fine for now. This will work. This code basically gets the embedding from OpenAI API, right? After this, we have our documents. These documents actually mean that we had these stores, right? So these documents are actual queries, actual documents. Let's say you have web pages, you have websites with these articles, these headings. So these are stored somewhere, and these documents, and these could be stored in a database or somewhere else, or you can fetch from APIs. So we'll be finding a similarity to our query. Let's say our query is, how can I improve my resume for tech jobs, right? This is the real purpose query, and I want to find similar results to this query. And these documents are stored somewhere on the internet that OpenAI has stored in their databases or somewhere else, right, in their vector databases. And so these documents, I'm gonna run this. This, and now what I'm going to do is create embedding for each of these document and store it into document vectors, right? This will take some time. It will make like 5 queries for each of these. It will make like total of 5 queries for each, one for each. After this, I have my query, how can I improve my resume for tech jobs, and I want to create a vector for my query as well. So I'm creating a query using OpenAI, and this is what I will be storing, and this is how that query vector looks like. So this could be very, very large. We are using 1536 dimensions, but it could be larger than that if you want more complex queries. So what I'm gonna do is we just change the shape of query vector to actually fit in our cosine similarity function. So this code is not required actually, but this is fine. This is just to check if there are infinity values or nonce values, because it could crash your other queries in vector databases. But for now, this will work, right? This is one. After this, I'm not gonna be using a vector database for now. Not required. This is also not required. I'll cover a vector database example in a different video. For now, I'm gonna be still using this cosine similarity function. So we find the similarities using the query and document vectors as required, and we fetch the top 3 similarity indices, and we print the result. So this is what's the result is 0.6 value highest similar value is this: how to write a great resume for software engineering. Second is best practices for technical interviews. So this is how your Google search or your Perplexity works. They kind of fetch similar results first, and then they feed it to the prompt, and then the prompt LLMs obviously, and the LLMs will organize the data in a better way and give back you the response. So these can also be like used to fetch the real-time data, real-time changing data. LLM doesn't have to generate the data, it can just fetch the news, it can fetch the yesterday's weather report, it can fetch your LinkedIn profile in the real time. So whatever you want to do in real time, you can fetch the similar results and then feed it to LLM for better responses. Right, so this video is done for now. In the next video, I'll try to explain cosine similarity as well as actually use a vector database example instead of using this cosine similarity function. Right, we'll be able to store our documents in a vector database and then retrieve the similarities from those. For now, thank you guys. See ya.